Good. Unit 6, Test Study Guide, question number 31. This section is about percent error. And remember, when we covered this, the main thing you need to remember is that it is the error over the correct or actual amount. Okay, that's the critical thing. Find out how much of a mistake they made, put that over what the actual correct amount should have been or would have been. Okay, so number 31. Mr. Yost counts his steps and estimates the distance from the Ramstein Middle School flagpole to the commissary door is 180 meters. The actual distance is 192 meters. Calculate Mr. Yost's error. First off, figure out what his error was. How much was he off on that distance? Just subtract the two numbers, 192 minus 180, and it really doesn't matter which way you subtract it. Use your calculator if you want, you don't care if it comes out negative, you're just going to ignore that it is negative. His error is 12. That is the error. And now what you need to do is make it as your error over the correct / actual amount. And this is going to be the percent proportion again. That is the right hand side of it. The error this time was 12. The correct distance, the actual distance, you've got the choice of using the 180 or the 192. The one that is the correct actual distance is the one that you need to put it over. How far off was he from the correct distance, the accurate distance, the actual distance? So it's over the 192, and we're looking for the percent, so it's x over 100. Solve your proportion, cross multiply. 192x equals 1200. To solve this equation, divide by 192, divide this side by 192, and you come up with calculator time. 1200 divided by 192, 1200 divided by 192. And again, guys, when you're using your calculator, be careful with it that you are typing the numbers into it correctly. This calculator is really nice because I can look back to see what I typed into it. And so you end up with 6.25, which is mostly the correct answer. But remember, this is percent error. This was the amount that's going over the 100. That is it, 6.25% error. Mr. Yost was off by 6.25%. Number 32, again, same thing. High school chemistry student completed a lab. He measured 62.5 milliliters of solution. The actual value was 63 milliliters. Okay, I hope I said that right before. Calculate the student's percent error. Again, find their error. So 63 minus 62.5. You can use your calculator, or you can put a decimal point, line up your decimal points when you add and subtract. Tack on a 0 so you can see how you have to borrow. This becomes a 2, that'll become a 10. 5 from 10 is 5. And the rest of that is 0. Your decimal point stays right in a row. So this is the error. He had a 5/10 of a milliliter error. Okay, so error over actual / correct, whichever way you want to say it. I'm just trying to make sure you choose the right number. It has to be the accurate measurement. So his error, 5/10 over, oops, there it is, the actual value was 63, so it needs to be over the 63. X over 100, we're looking for a percent. Cross multiply, you get 63x equals 5 times 5 tenths times 10, it's going to become a 5, and then times 10 again. It's going to be 50. If you don't trust me, please run it through the calculator. You know what? I'll do it too. It is 0.5 times 100 equals 50. There it is. And so divide by 63, and you're going to get x equals, actually I'm going to go over here, x equals 50 divided by 63. You come up with 0.793605, and then it starts to repeat, 793. I would say rounding off to 2 decimal places is accurate enough. The hundredths column has a 9 in it. You look to the right, it's a 3. So that 9 would stay the way it is, 0.79. And again, this is percent error. That is the percent error. Less than 1% error. Okay? And that is our answer.